Hello and welcome everyone. My name is Ravi Sharma and I'm the National Chapter's representative and board member of PanIIT USA. On behalf of PanIIT USA, it is my proud privilege to welcome you to this webinar session today. Artificial intelligence as a predictive technology has been around for a long time. But large language models such as ChatGPT, announced about a year and a half ago, brought to light the generative powers of AI. And this has created an unprecedented excitement about AI. Really, when it comes to generative AI or generative capabilities of AI, many of us are baffled to see and experience the incredible potential of data and information. Although anyone would tell you how impressive and mind-blowing some of the large language models like ChatGPT are, the fact is that they are anything but perfect. And they pose a fair degree of risk unless you truly understand their inner workings and utilize them appropriately. Today's webinar may help you develop a clearer understanding of generative AI and the large language models that are behind applications such as ChatGPT, Google Gemini, etc. This webinar is second in the AI Frontier series of webinars being organized by PanIIT USA. This series of webinars aims to present to you some of the global thought leaders, outstanding academics, and expert practitioners in the field of AI. We have some great speakers lined up to talk on this forum. Our guest today is Professor Subbarao Khambampati, popularly known as Rao. Dr. Rao is a distinguished alumnus of IIT Madras, as well as University of Maryland, where he obtained his master's and PhD in computer science. Dr. Rao is currently a professor of computer science at Arizona State University. He studies fundamental problems in planning and decision-making, motivated in particular by challenges of human-aware AI systems. He's a fellow of the Association for the Advancement of Artificial Intelligence, the AAAI, the American Association for Advancement of Science, the AAAS, and ACM, the Association for Computing Machinery. Professor Rao was an NSF Young Investigator. He served as the president of the Association for the Advancement of Artificial Intelligence and as a trustee of the International Joint Conference on Artificial Intelligence. He also served as the chair for the AAAS Section T, and he is a founding board member of Partnership on AI. Professor Rao's outstanding research, as well as his views and ideas on the progress and societal impacts of AI, have been featured in multiple national and international media outlets. There will be an opportunity for you to ask questions after the first part of the session today. Please feel free to put those questions in the Q&A window, and we will take them up. And now, without further ado, let's welcome Professor Rao. Professor Rao, thank you for taking the time out of your busy schedule and joining us today. You may please proceed.
Thank you. Are you able to see my slides?
Yes.
Okay, good. Thank you all for showing up early on Saturday. I still remember my IIT days, and I know that Saturday nobody wakes up. So it looks like some of you have grown up, just like I have. Anyway, so I am going to be talking about LLMs and demystifying LLMs. So since this is a PanIIT forum, I should probably kind of establish my IIT connections. I went to IIT Madras, 78 to 83. I hope some of you at least were born by then. And then, so I stayed in Alkananda first year, Jamuna second year, and Tapti for the last 3 years. Those were the days when we used to have real 5-year education, unlike this watered down 4-year education they give these days. So in case you're wondering where I am in that picture, that's me, and I had hair at that time. And then in 2022, I had a chance to go back to IIT Madras to get, enjoy like the hanging around in the campus in the nights and also getting the Distinguished Alumnus Award. Okay, so we're going to talk about LLMs, and it's all about AI. And so the question in general is, everybody is already an expert in AI. If you go by my LinkedIn feed, everybody has already become an expert, are mostly working in responsible AI, which I don't know what actually it means. So I, unfortunately, am a slow learner. I started, I think, working in AI back in 1983, 82, 83 timeframe at IIT Madras. That was my bachelor's project report on speech recognition. And this is Professor Ignarana. Those of you who went to IIT Madras may remember him, and he was my advisor at that time. Okay, and then here at ASU, I been working within AI. I'm working in planning and decision making mostly, and in the last decade or so, I've been quite interested in human AI interactions. How do we get AI systems to work as if they are teammates with us humans? And that's my background. And there's pictures of my students and some books that we have written, and some robots, etc., just to kind of say that, yeah, there are robots. That brings us to the agenda for today. The agenda for today is it was actually hard somewhat to figure out what is the level at which to explain things to you. On one hand, Yalara, you are all from IITs, so presumably you'll understand everything. But on the other hand, not all of you are from IIT Madras, so there is also a question as to the level of understanding. And so I had to kind of figure out a reasonable thing. Seriously, I actually tried to make it a semi-technical, with focusing more on the technical capabilities and limitations of LLMs than about the societal impacts, which we will discuss maybe a little at the end, but that's almost a separate talk altogether, and that I have done those separately. So I won't walk you through the agenda right now. It will become clear as we actually walk through there. So the first thing I want to get you on board is there are like two broad trends that happened in AI in the last about 10, 12 years. And to understand what's going on in AI with a reasonable background in where the ideas are coming from, it would be useful to know these two trends. The first trend essentially is the early on when AI started. AI, as some of you might know, was the only field which actually had a specific conference where they started the field, 1956 in Dartmouth. So when the field started, basically, in the beginning, it was more about going from explicit knowledge tasks, working on tasks for which we know how to do them, so we can actually program them for the computer and then manage the search complexity, etc. This is what happened, for example, in 1997 when Deep Blue actually won over Kasparov. The focus steadily shifted from explicit knowledge tasks to tacit knowledge tasks, where we do these tasks, but we don't quite know how we do them. When we walk, we know how to walk, but we don't exactly know how we are controlling all the joints, etc., to make sure that we are not falling off. We are not consciously aware. And similarly, recognition, perceptual knowledge in general is very much tacit, vision, speech, language, etc. And so AI started getting more interested in the tacit knowledge tasks. If you look at on the right-hand side top, the funny part is kids come into the world first doing perceptual intelligence, emotional intelligence, etc. And AI systems went in the opposite direction, going from explicit knowledge tasks and reasoning to tacit knowledge tasks and perception, etc. And the second part, of course, is that we used to have systems that reason from specification. So mostly the specification of the model is given by somebody. These are sort of the model-based systems. And most of the technical issues would be in terms of ensuring that the search complexity is handled correctly. To actually learning from the data, because with the tacit knowledge tasks, we don't know actually how we solve these problems. We don't actually know how we see faces, how we recognize cats. And we basically had to give up on providing model-based approaches for those things, and then go whole hog into machine learning approaches to actually make a big breakthrough in vision and speech, etc. So that's the trend one. The trend two, which you also want to keep in mind, is that earlier on, AI systems used to go focus on deep and narrow systems, not just earlier on. I mean, I think, yeah, mostly even in the recent 8 years, if you think of something like AlphaGo, that's a deep and narrow system. It's a system that can do superhuman play on Go, and yet it has no broad knowledge of anything else. And then we went from that sort of a systems to broad and shallow systems, where they have basically, they're like the jacks of all trades, but masters of none. Essentially, these are systems which have broad knowledge about huge areas, but are not guaranteed correct in any one of them. And if you think about LLMs, actually, they fall in the broad and shallow category. If you think of AlphaGo, that falls in, or even AlphaFold, it falls in the deep and narrow category. The other technical part is we went from a machine learning perspective, we went from discriminative classification to generative learning, or generative imagination. So the idea there is, instead of showing pictures of cats and asking the system to classify them as cats or dogs, etc., we were essentially trying to basically make the systems learn the distribution of these objects, and such that you will wind up learning the joint distribution of those objects in manifold that they are embedded in. And this way, you can have systems that not only recognize dogs, but actually can draw you a picture of dog. And so the recent trend has really become to learn the distribution of the objects. This word you want to keep in mind, essentially learning some high dimensional probability distribution of how the various, let's say, images or the text is distributed in some manifold. And so, for example, that has been called the generative AI. So technical definition really of generative AI is their learning distributions. And so if you want to think of LLMs are broad and shallow generative systems for language. Actually, they can also be used for any sequential data. And of all the things, the most interesting sequential data we deal with is language. And so that's the first use we have had. There are other ways of using LLMs, but basically they can be used for any kind of a sequential data. So the scope of today's talk is we'll focus mostly on auto-regressively trained large language models, which is basically most of them that are out there. And LLMs, as I said, are one part of generative AI paradigm of learning distribution of the language, vision, and audio. So generative AI in general basically learns distribution of any kinds of objects. LLMs are a specific subset, which are basically learning the distribution of the sequential linguistic data. We'll also focus mostly on the capabilities and limitations of LLMs, rather than think about equally important thing, which is the fact that now they are available widely. What are the societal and ethical impacts? I'm assuming that pretty much everybody on the list of audience here has essentially, I think, basically played with ChatGPT and have thought about things like, oh my God, are there going to be college essays? Is there going to be a plagiarism problem, etc.? We'll talk a little about that, but mostly I'll focus on the limitations and capabilities and limitations. And since I said the word limitations, and in general, when you go to an LLM talk, it's always a lot of hype. Basically everything is great about LLMs and so on. And since I specifically want to, and part of it is basically, as Ann Landers said, rose-colored glasses are never made in bifocals, because nobody wants to read the small print in dreams. And LLMs have hit us so hard that now it's like a huge dream about AGI is around the corner and all that stuff. And there are enough influencers, quote unquote, trying to push that narrative. I do want to actually tell you that they're pretty amazing, but they also have pretty deep limitations, which you can't just get out of by increasing the size of the LLM or data or the compute, unless you actually make changes to the architecture, which we don't yet know how to do. So that is the kind of thing that I'm going to get you to walk through. And so the picture there is, I know that if anybody tries to say anything slightly not positive about LLMs, they would look like these mean people who are trying to kick a cute puppy and so lose a lot of audience. So I want to quickly assuage you that no, I'm not trying to kick the puppy. I think LLMs are amazing, but we really want to understand both strengths and limitations of a technology if you really want to use it and advance it. If on the other hand, you want to become an AI influencer, you can essentially just be either blind cheerleader or unalloyed cynic. And I want you to consider being the first rather than the second. And then one of the other interesting things is that LLMs is this technology where we know they're working, but we don't completely understand exactly why they work. This is very, very different from computer science in general, that if you write an algorithm, you know exactly what the properties are, and you can prove that the algorithm has the following properties about these outputs, etc. In general, LLMs and generative AI has started an era of an ersatz natural science in AI. There's a CACM blog article that you might want to look at, where essentially we are kind of trying to poke these things that we have, these organisms that we have generated, these LLMs or the VLMs and so on, and trying to understand what their capabilities and limitations are. And unfortunately, I mean, for example, zoologists do this all the time, right? I mean, they actually find animals that exist and try to make sense of what their behavior is. We just made our own animal, but we don't know what its behavior is, and we're trying to figure out. And this kind of an ersatz natural science, has some pitfalls, especially when people from computer science wind up doing it because they don't have much of a background in that sort of a science. And so they wind up making all sorts of mistakes in over or under appreciating the capabilities and limitations. I somehow thought about this yesterday. I don't know how many of you are Simpsons fans. In Simpsons, actually, there's this one episode where this, the soccer game comes to Springfield, and they basically show two commentators both looking at the same exact game. There is the guy, the Spanish guy, who essentially, there's nothing really happening in soccer. Most of you kind of know that. Oftentimes, people are doing there are not too many goals, etc. So you can, if you're not into that, then you may think that not much is happening. The Spanish guy thinks that every small move in the ball is like amazing. So he's like, hyperventilating. And the white commentator, the English commentator says, yeah, they're just basically going through the spaces. Since you tend to hear a lot more about the Spanish commentator about LLMs, the more hype-oriented thing, you're going to get the somewhat more a staid commentary on LLMs today. That's the thing that you want to understand. So with respect to LLMs, I basically have spent time thinking about them, like many of you, obviously, and I also written popular articles. There's one on the Hill, and then several on the popular in the sense popular for educated public on LLMs and their limitations. And, I have talked to the media and so on and so forth. That's about sort of public outreach, but I also have my students and I have papers in a variety of forums about, in particular, our interest is understanding limitations, LLMs limitations in planning and reasoning, whether they actually have any such capabilities. And it became important because multiple people mistakenly think they actually have such capabilities. And so I just want to show you that these things exist. By the way, whenever you see a QR code, that basically is the code for the that particular URL for where the papers for this are. And whenever you see the agenda, there is a QR code there. That is the slides QR code. By the way, it turns out that this stuff, AI is a surreal field to be in right now. The stuff that we are doing, that we published in New Rips in last December, got discussed in New Yorker. New Yorker has an actual column on annals of artificial intelligence. They don't have a column on annals of databases. They have one on annals of AI because it's become a big thing. And so they talk about some of the work that we do. And finally, before I go into the LLM background, I spend a bunch of time trying to explain and try to deal with the misconceptions about this in my social media accounts, Twitter mostly, and sometimes I copy it over to LinkedIn. And in fact, since many of these things were posted there, I might have on the sides of the slides the actual Twitter threads in case anybody wants to get more details on those. So come back to the agenda. As I said, the slides basically are available at that QR code. So now I'm going to start talking about the basics of LLMs. And so basically they are n-gram models. And so text is a long sequence of words. An n-gram model of a language tries to predict nth word given the preceding n-1 words. So probabilistically speaking, you're trying to, given a bunch of data, bunch of linguistic data, you are trying to compute these conditional probabilities, probability that the nth word would be a particular vocabulary item, given the first two n-1 words preceding that word. Okay, so that's what you're trying to guess. And these n-gram models have been around forever. Claude Shannon, the guy who actually started information theory, was actually playing around with them. But mostly we were talking about n-gram models for n very small. So a unigram just predicts, if I don't tell you any word, what is the most likely word you think I'm about to say? In English, it would turn out to be the, right? For example, the is the most popular word. And so that's like the prior probability of words. And you sample from that, and then you bring out the word. Bigram model, given one word, what's the next word? Trigram model, given two words, what is likely to be the next word? And from that perspective, ChatGPT, the one that got this whole thing going back 2 years back in November of 22, essentially is a 3001 gram model. That means given about 3000 words in the context window, what is the most likely next word? So it's trying to give you this probability distribution of the next word given the previous 3000 words. Okay. Now, a power of the n-gram model depends on how much text it trains on, how big is the n, which is the context, and how high capacity is the function it is learning. Because in essence, we'll see in a minute that representing these probability distributions in uncompressed form is essentially impossible. So you're going to wind up compressing them. And when you compress them, in general, whenever you do some kind of when you do your compression, you do wind up doing some kind of a generalization. The question, of course, is whether generalization is good or not. And we tend to see anecdotally that it seems to be a pretty good generalization. Okay, so in the case of ChatGPT, it trains on about 600 gigabytes of text, at least the original one. Now, it hasn't increased that much more, because one of the things that you want to remember is the web happened not because Sam Altman asked us to have web, but because we created the web for each other's use. We wound up just putting all our stuff on the web. And if it didn't happen, and if you had the rest of the technology, getting 600 gigabytes of human collective subconscious would be essentially impossible. So this is something that people don't understand and you want to keep in mind. The other thing is, for the ChatGPT 3.5 itself, it learns 175 billion parameter function. That means this conditional distribution is essentially represented as a high capacity function, which has 175 coefficients. And it just function happens to be approximate, represented by a neural network. And the vocabulary there is about 50,000 words for ChatGPT 3.5. Okay. In case, so the question, of course, is how does the training work? And so I want to give you, for those of you who may not have thought about it, here's actually all the text on the web, all the linguistic text on the web is essentially like, sequence of tokens, essentially word tokens. And you can think in terms of word tokens for now, that should be fine. And the question, of course, is what it will do is essentially it will, during the training phase, you do what's called autoregressive learning, and which, if you don't like the word autoregressive, you can call it self-supervised, which is a newer version of the same name. But the basic idea is, suppose you have the following sentence. Let's say all other IITs are in eternal awe of IIT Madras. So this sentence, you pick it up, and then you essentially say, if I give all, what would be the next word? If I give all other as the context, what would be the next word? If I give all other IITs, what would be the next word? This is the training data for each of which, given its current 175 billion parameters initialized, the system comes up with suggestions as to what the next word is likely to be. And then you happen to know what the actual real word is because you are looking at this particular sentence. So on the right-hand side, LLM might use its current function to guess the next word, showing when shown all, it might just say right is likely to be the next word. All right tends to be a pretty reasonable completion of all. So it says all right is the next word. So guess is right. The word right, but the correct word is other, according to the data that I have, because all other is the next word in the sentence we have on the top. So basically, then there is an error. So what it predicted was right. What it should have predicted is other. So the error is other minus right. Okay, so you just have to subtract the other minus right and then propagate this error back through the network. And I'm not going to teach you, I'm not going to talk about how neural networks are trained. I'm hoping that you have an idea of that. In general, if you have the error at the output level, this loss function, then essentially you can do automated backpropagation through whatever is the largest, however big the network is, you painstakingly backpropagate this error, making changes to the weights in terms of the gradients at that point. And I'm assuming that many of you know about this. Two important points is that the words, what's the difference between the word other and right? Well, it turns out those words themselves don't have any clear-cut numerical difference. But the other thing that happens in LLMs is you convert all the vocabulary into sort of an embedding space. So for GPT 3.5, the vocabulary size is 50,000 words, but you wind up essentially computing word embeddings using something like autoencoder sort of things, which is better ideas, of course, but you can think in terms of autoencoders as a first idea to come up with is a representation of these words as vectors in a smaller dimensional space. So in the case of GPT 3.5, actually, it looks at a 12,000 dimensional space. If obviously I can't show you 12,000 dimensional space as a picture, so there's a picture there showing a 3-dimensional space and words put as vectors in that space. And the typical sense then is each of these words are vectors in this high dimensional space, and the difference then would be the difference between the vectors, and so you now have the numerical values of the vector error, which you can then backpropagate. Okay, and then backpropagation itself is just essentially chain rule of derivatives that we all learned, like before even getting into IIT, we wouldn't have gotten into IIT without actually having chain rule done. And then you do the chain rule with dynamic programming. That's the auto differentiation or backpropagation. This is the basic workhorse of our neural networks, and that's what you wind up doing. And that's what is involved in training the neural networks, training the LLMs. That's all fine, but what's hard essentially is sort of, think of this old joke about Archimedes, who, when he learned the principle of lever, he said, just give me a fulcrum and a long enough stick and I can lift the universe. The principle of fulcrum basically says you can essentially, the principle of lever says that if you put the stick with the short end towards the weight and the long end at your hands, then you do have to put less force, as you can know. Except the question is, can you actually use it? What actually happens to it when the scale has become ginormous? So in the case of ChatGPT 3.5, the problem really is the vocabulary size here is 50,000 words. And so if I have n minus one as the context, then I can have essentially as an upper bound v power n minus 1 potentially different context, n minus 1 sized context windows. For example, for the case of ChatGPT's 3001 gram model, with a 50,000 vocabulary, we were looking at a whopping 50,000 power 3,000 different contexts. For each context, you need to know if that's the 3,000 words, what would be the 3,001th word? What's the conditional distribution for that? So the number of conditional distributions you have to learn is 50,000 power 3,000 for ChatGPT 3.5. Now, if you ask Google what it is, it'll say infinity because it's a ridiculously large number. And so when you are getting impressed by 176 billion parameters of ChatGPT 3.5, don't be. Really compare 176 billion to 50,000 power 3,000. So in essence, you are representing a huge number of conditional distributions with basically a vanishingly small fraction of coefficients for the function. Okay. And one of the interesting things about compression is one of the things that this compression actually winds up playing a role in is two different ways. One is, think about the following thing. What is the chance that you will look at the exact 3,000 words in the exact same order more than once, even at the internet scale web corpora? That's basically vanishingly small. So what you'll wind up doing in compressing is, effectively what you'll wind up doing is two contexts, even if in fact they are differing in some words, they might be considered to be in the same equivalence class. That's what the compression winds up doing. And then the other interesting thing is, if in fact you went with the original view of essentially every context being different from every other context, and there are 50,000 or 3,000 contexts, then the conditional probabilities will all be degenerate. It will basically be for the one particular time that context occurred, and whatever is the word that occurred as the 3,001th word, and zeros everywhere else. So those are degenerate distributions. Instead, what you'll wind up getting when you learn this function using, in this particular case, we wind up using transformers, is essentially where there used to be ones, they become non-ones, and where there used to be zeros, they become non-zeros. And so effectively, you have shifted, you have a sense of what the word is going to be, even if in fact this particular prefix has never been seen. So this is where this some sort of an abstraction is going on during this training over this information. Now, the other thing that people don't quite get, and it's kind of important to keep in mind, is the mental picture of basically the transformer network. I mean, and I'm not going to look at transformer network and teach. I mean, I have lectures on that, and other people have lectures that you can look at. But it is a particular type of neural network. So people might have a picture like the one on the left-hand side. It's some big neural network, and maybe a big being, that sort of a thing. But really, they don't really realize how big that big is. So if you think of GPT-4, this is a graphic actually James Campbell made, which I just copied. The training size in terms of the data training that it is trained on, if you actually put that all in books, then the bookshelves will be 650 kilometers long bookshelves. So let that sink in. The second is compute size. If you are essentially trying to train GPT-4 on your pretty darn good, Apple Mac or something, Mac Pro or something, it will take about 7 million years. And then finally, the model size, for GPT-4, it's 1.8 trillion parameters. We went from 176 billion to 1.8 trillion parameters. And that will take like an Excel sheet of like 30,000 football field sized Excel sheet. I'm putting that out just so that you have a sense of the scale of this function. One of the beautiful points about use of higher dimensional math in computer science and data science is when higher dimensional math was used outside in general engineering, it was 3 dimensions or a few more than 3 dimensions. Here, we are talking about essentially the dimensionality and the sizes of the problems are much, much larger. And that sometimes beggars our imagination. So ChatGPT is completing your prompt by repeatedly predicting the next word given the previous 3,000 words, right? And then, of course, it's learning a high capacity function with 175 billion parameters. In that case, by GPT-4, it became 1.8 trillion parameters. And it seems to be given any, you can say that all conversation is trying to essentially figure out the next word, the next word, the next word. As I'm speaking, I'm trying to figure out what would be the next word I say, what will be the next word. And if it's an actual bidirectional conversation, if I'm taking breath, then you will say something, then I will still have to consider what I said, what you said, and what's my next word going to be. And so you can say at some level, it's all about completion of prompts. And so the real question is, and more interestingly, many of you who played with ChatGPT have found that the prompt completion seems to be pretty reasonable. It's actually kind of good quality completions. So they can write essays, they can write poems, they can give you explanations about, like say this was a little old side, Silicon Valley Bank failing, and also, of course, that TIGZ code for sketching a unicorn. And we are essentially writing language, full-on language to them as prompts. And the interesting question is, we also talk to dogs in full language, and it's not quite clear whether or not the dogs understand everything we say. LLMs understand more than the dogs, but we don't quite know whether they understand language the way humans understand. And this brings in all sorts of interesting misconceptions that we'll talk about in a minute. So the question, of course, is why are these prompt completions so good? Actually, why is it that they're capturing like the general effective style of the language? One of the things that I'll keep repeatedly pointing out is that generative AI systems learn the distribution, not the content, but the distribution of plausible content. And they basically write pretty reasonable, plausible content. And why is that possible? As far as we know, we don't have very good ideas right now as to why this actually happens. But some possible factors to keep in mind is two things. One is almost everything we know is already on the web, and it is fodder for LLM training. It's not that LLMs are actually retrieving, indexing and retrieving. I will tell you in a minute about this notion of approximate retrieval, which is a much better metaphor to understand what they're actually doing. And then also, while we think we understand n-gram models, we tend to have a sense of n-gram models for n equal to 1, 2, 3. We don't really have a sense of what n-gram models are for 3,000 word context. And so we are continually surprised. So those are things to keep in mind, and because of which we have become a search natural science, where we poke the LLMs to figure out what are they doing? If I say this, what are they doing? And write papers about these prompting strategies and so on. So I told you that I want to talk about LLM approximate retrieval. So the approximate retrieval, you know that in databases, there is retrieval going on, and which is given a query, that is a key, retrieve the records that exactly match that query, right? So if you are thinking in terms of New York Times database of all articles, let's say, each article probably has a particular article identifier. And so if you give a query in terms of the article identifier, then essentially the database system will send you exactly that article back. Okay, so that's your retrieval in databases. Retrieval in information retrieval systems, such as Google, you generalize this idea a little bit and say, I don't have the exact keyword, the exact key for the article, but I know the kind of words that are present in the title of the article or something. So I give a textual query of some words that are present in that article. And then what the system is going to do is retrieve all the records that are similar to the query. So if you think of the query itself as a document, the records as a document, then you're looking at the inter-document similarity. And this is how Google works. The important thing to remember is the record themselves are actual articles that New York Times has stored in its database of articles, and it's going to pick up a bunch of the top K ones that seem to be basically similar to the query you give. Okay, that's the retrieval in IR systems. Approximate retrieval is what happens in LLMs, where it's basically you're no longer actually picking the article from a database, you are making the article up using these conditional probability tables that you have learned. So instead of a database, essentially, I have that picture of a toothpaste. Essentially, the entire database, the web database, is no longer kept as web. It's kept as this compressed function of 176 billion parameters, which can then, given this query, will start predicting the next word, next word, next word. And so in essence, it's writing in front of you a document. And this document doesn't actually exist, doesn't have to exist in New York Times database because it's just being made up. And the interesting thing is it will be similar to the date articles that might be present in the New York Times database. So this is basically the interesting part. They are making up information on demand. That's why they're creative. That's why if you want to write a new essay on the cow or the family cow, you can ask it and it'll give you a new essay on the family cow. And hopefully no Turnitin system will be able to tell your teacher that you actually copied a very specific article, essay of your friend, because it's actually going to be different somewhat. But at the same time, people like the creativity of this aspect of this, but it's both the boon and bane of the LLMs, because they can't stop being creative. They can never guarantee that the document that they made is exactly present in the New York Times database. And if not, then there may have been pieces that have been changed, and that those pieces might actually be factual pieces. And so factuality can get lost with LLM approximate retrieval. So you may have heard of the word hallucinations with respect to LLMs. So you may have heard that LLMs sometimes hallucinate. I would like to tell you that because they're anagram models and they do not index and retrieve, all they ever do is hallucinate completions to the prompt, such that the completion is in the same distribution as the text they have been trained on. Okay, so it's like, looks like a New York Times article. In fact, people have called LLMs the vibe machines or the style machines, because they will convince you that it looks like a New York Times article, but it's not one, so it's not necessarily factual. Prompt engineering doesn't change this. We will talk about prompt engineering techniques, but it doesn't change this, because whether or not changing the prompt gives a factual completion depends on the prompter knowing enough to tell whether the given answer is an accurate one, which is why, my biggest contribution to AI these days is that particular adaptation of XKCD cartoon. I'm also selling t-shirts on this, believe it or not. I'm kidding, but I actually have a t-shirt I wear once in a while. That the entire impressive factuality and reasoning abilities of LLMs depend on the prompter actually knowing the answer. So if you ask the LLM, make the essay, have smaller paragraphs, and then it came up with an essay with the smaller paragraphs, you can tell that there are smaller paragraphs, you are happy. On the other hand, if you asked the LLM, what is the capital of Belize, and it gave some city name, it will give you a city name for sure. The question is, do you know for sure that that is really the capital of Belize? Of course, you might say, if you happen to know, then why are you asking the LLM? If you don't, you have to go back to Google and figure out what the actual city is. So there never is any guarantee that what this thing made up is actually factual. Okay. But they are amazingly good idea generators or muses for your work. If you are getting stuck, about how to write something, or about to write an essay or something, you might get like a first draft and then spend time trying to improve it. Although, depends on how good a writer you are to begin with. But LLMs are pretty good idea generators. And we all need idea generators in our life. Once in a while, we'll get stuck. And so it'll give you something that you can refine, and you have to spend time refining. If, on the other hand, you don't, and you assume that, oh, because LLM gave it, it must be real, then you would be like that lawyer, which we'll talk about in a minute, who gave this case briefing to the court, where LLM made up all the case names and docket numbers because they looked like reasonable case names and docket numbers. And it turned out that those cases don't exist anymore. They never existed. And so the judge basically fined the liar. Okay. And so LLMs are amazingly good cognitive orthotics, and that's a great way to use them and to help us. And I'm not the only one. Lots of people think that's a great way to use it. I think most of you actually use it in day-to-day use. Google is not AGI, but we use Google all the time. LLMs are, kind of can be used in the similar way with human in the loop. So when New York Times asked me about chatbots, I basically said, if you don't know an answer to the query already, I would not give the question to one of these systems, which is what I was telling you earlier. And if you thought only I am like pessimistic like this, a couple of months later, the guy who runs BARD project at Google essentially said the same thing, that, essentially you can't be sure of actuality. The important thing here is a civilizational one. Essentially, we always have conflated style. I mean, there is a style versus content and form versus factuality. And we basically sort of made assumptions that good style implies good content, good form implies good factuality. I mean, I'm from IITs, you are from IITs too, and I'm sure that, behind the back of our heads, we thought the guy who speaks in high vocabulary and without any grammatical errors probably knows what they're talking about. It's a nonsensical assumption to make, but we made it and we got along fine because there was some correlation between style and form because of the way the society is organized, even though it's causal, even though it's not causal. But with LLMs, essentially, style is something that comes free. We always assume style is hard to get, but LLMs and generative AI in general get the style freely, very easily. In fact, which is the reason why if you played with DALL-E, etc., you can make it draw paintings in Gemini Rai style or Picasso style, and it does a pretty darn good job because it got the style of the various subgenres of paintings. And similarly, you can get that for LLMs in the language. Correctness, style is a distributional property. And so there's a bunch of pictures that you'll say they look like Picasso's paintings. It's a distributional property. Correctness and factuality is, in addition, on the other hand, is an instance level property. LLMs actually cannot guarantee it. No, normally, generative AI cannot guarantee instance level correctness. Civilizationally, we had always thought that the style is harder than content, and even assume that good style implies good content. But LLMs and generative AI in general are turning this intuition right on its head. And that actually is part of the reason for a lot of angst about using LLMs in general. So for example, ChatGPT invented a sexual harassment scandal and named a real law professor as the accused. This is one news story. ChatGPT falsely told voters their mayor was jailed for bribery, he may sue. Canada lawyer under fire for submitting fake cases created by the chatbot. And finally, most recently, Air Canada had to honor a refund policy its chatbot made up. Okay, and so basically, it said, yeah, you can get this refund on these conditions, and basically it turns out that that was not the company policy at all. It just made up company policy, and Air Canada tried to say, no, we are not responsible for what ChatGPT made up, and judge said, no, if you use ChatGPT as your customer service representative, you are damn well responsible for what it says. Okay, so that's bunch of things that are done already. We looked at trends in AI technology, LLM basics, LLM as doing approximate retrieval, and the whole notion of hallucinations and understanding that they're always hallucinating, and sometimes their hallucinations, align with your reality, and whether or not you can say that that alignment happens depends on whether you know your reality. Right? That's an important thing. And then the style versus content and form versus factuality issues are very important to keep in mind. Now, a couple of more things than the rest of the talk, I'm going to look at some quest to improve factuality. So if you want to, somehow people are interested, even though they started as this nice prompt completion engines, people are interested in having both completion and factuality. And so generally improve the LLM responses, both in terms of the style and also most interestingly in terms of their factuality. And there's a bunch of techniques that have been proposed. None of them are foolproof. There is the prompting techniques, prompt engineering as a whole entire thing. This is a busy slide. I've made the slides available. You can look at them later on, but I'm going to give you just the highlights. That prompting is actually, that is a good thing because it just doesn't change the LLM parameters. And it's sort of in context learning. So you're just changing all the conditional probability tables for every possible context window, context window have already been pre-computed during the pre-training. All you are doing is by adding extra words to the prompt window, you're changing the specific conditional probability table you will wind up looking into. That's basically what you're doing. And people tend to think that prompt engineering actually helps stuff, but as I'll say in a minute, whether it helps stuff or not depends on, first of all, it helps in cases where you are part of it's a human in the loop process where you know the correct answer that you're looking for, and you're trying to give LLM to get you towards that. And it's one of those cases where generating the answer is too painful for you, but checking its correctness is easy for you somehow. In those cases, prompting actually could help. Fine-tuning is another idea that basically it changes the LLM parameters. So in essence, you have a pre-trained LLM that's been trained on the web scale data, and somehow you're only going to now say, I want it to talk much more like a New York Times article. Then you further retrain the last couple of layers, for example, in terms of by basically providing, by making it just retrain additional data only from the New York Times documents. Okay, what that does is it changes actually the, some of the parameters of this 176 billion network weights, and it changes, because of which it winds up generating different completions that might be more desirable to you in sense. But remember that fine-tuning can never, it's only changing the conditional probability tables. It's like even if you actually train on fully factual data, LLMs can still hallucinate, because all they are doing is they're not indexing and retrieving, they are essentially putting word after word. I'll say that in a minute again. In general, when people get impressed by LLMs, which I think good reason to be impressed with, because they do seem to provide these nice things in correct style. And if you if you check the correctness, you're in good shape. But one of the things is when there are things like factuality and reasoning are involved, people give too much credit to LLMs when they're actually pushing the LLM towards the answer they know is correct. And to keep that in mind, you may want to remember, for those of you who haven't heard of it, this great horse called the Clever Hans, which used to be there in the turn of the century, Germany, and it would know how to do arithmetic. So it almost could have gotten into JEE, in those days, basically because it's a horse that can do arithmetic. And the idea is if you ask it 7 plus 5, it will then stomp its hoof 12 times. And so it was doing it reasonably correctly, that this guy who is the owner, the guy in these big long robes, looks like Rabindranath Tagore to me, essentially would take this horse from place to place and, show horse and then get money, etc. And then some psychologists, Killjoys, who basically did experiments on this horse and figured out that the horse doesn't know numbers and arithmetic at all. All it is doing is sensing the facial expressions and the stress level of its owner. And so if you say 7 plus 5 and the horse starts stamping, and when it reaches about 11 or 10 and 11, the stress level for the owner increases, because you're hoping that after 12, it will actually stop. If it continues, that'll be a wrong answer. And it checks that and then it stops at 12. And that's basically what they pointed out. And they basically had the guy outside, away from the horse's side, and the horse turned out not to be able to do arithmetic anymore. Right? So it wasn't, the arithmetic was not being done by a horse. Arithmetic was being done by the verifier, who is this human. And then they were giving the signal to the horse when to stop, unbeknowingly. And so that's something that you want to keep in mind. It's okay if you want to get this work done with the LLM and you are enjoying the cooperation that you get from LLM. But remember where the credit is. You are the one who knows the right from wrong, and then you are essentially giving the signals to LLM. Some of you have heard of ragging. I haven't heard of ragging after I left IITs, but now ragging is all the rage. So rag basically is this silly, somewhat of a silly idea that LLMs are too creative. And remember, one of the things I tell when I give these talks to the courts and judges is, if a witness stands up and says, Your Honor, I'm a creative witness, you will first throw them out of the court. You don't want creative witnesses. You want witnesses that tell it like it has happened. But LLMs cannot stop their creativity. Essentially, they are, they're doing approximate retrieval. So one idea of making them more factual, in particular, imagine, let's say Air Canada wants to have ChatGPT as a client, but it wants to not make up new reimbursement methods, new refund methods. And so it wants it to look, not fine tune, but look at its database of all its procedures, the company procedures and doctrine. And that would be essentially in a what nowadays is called vector database. In fact, the simplest way of thinking about RAG is LLM taking the prompt, giving it to Google, taking the top couple of answers and take those documents and summarize those documents. So you're using LLM to summarize rather than generate the entire document from scratch, because the hope is that you would be it is less likely to make up stuff when it is actually summarizing than when it is making up the entire document. But it's only a hope. It turns out there are papers right now that show that even the summaries that LLM makes are actually not factual. There's never any guarantee about anything that LLMs do by themselves. That's something that you just have to get used to. But summaries tend to be a little less egregious errors maybe than if they made up the entire refund policy. Okay. By the way, with all due respect, if you just directly use LLMs to do search, which is what Perplexity used to do, Perplexity, the search engine that one of my alumni, one of the IIT Madras alumni has started, it basically would actually use LLM to do the search directly. And so it would make up all kinds of information. The running joke is I can give myself a Turing Award. I can give myself a Nobel Prize, anything, because Perplexity will just say, yeah, you have all of those. And nowadays, it's a lot more. There are fewer errors, partly because, and in fact, it's been admitted by them that they essentially use sort of a RAG style with almost Google as the RAG database. And again, when you think of RAG, essentially that's IR, and LLM is the approximate retrieval. The IR thing will actually give you a document that is stored. It's not going to make up. Google never makes up pages. You may say that's a bad thing, or you may say that's a good thing. If you're interested in factuality, then it's never making up pages is a good thing. Okay. The training data quality matters for LLM performance. This is understood. Quality of training data matters in improving the quality of the LLM completions. This is why most modern LLMs are trained by essentially reweighting all the data corpora that is available on the web. The web corpora actually also has 4chan corpora. And the 4chan is typically removed. That means it's given a weight 0 so that it's not actually used in the training. Similarly, they might actually use upsampling to make some of the good data be presented to LLM more often during the training. So for example, you might show Wikipedia more often and New York Times more often. And then some of the general Reddit forums, etc., maybe much less often, in terms of actually training during the pre-training phase. When the data is not readily available, getting it can be quite costly. Web contains, because of multiple reasons. One is, of course, web just happened for ourselves. We didn't make it happen because Altman told us to do so. And if in fact Altman says, just can you guys make other web? We'll say, screw you, we are not going to do it because we have other things to do. But web contains mostly correct data. We put stuff about how certain things have been reached, but not the corrections data, not as much the corrections data. You don't, in fact, it happens a lot more actually in things like GitHub, where pretty much most people upload only their correct programs. There is sometimes some limited information about errors, the version changes in the GitHub that can help get you some corrections data. But in general, web is a lot more of correct data than the corrections data. And the derivation and the thought behind the data that went into making the data up can be quite expensive. And in fact, OpenAI found it for the hard way because they essentially had to, in one case, they tried to kind of get the derivational data behind how, for example, certain problems, certain benchmark problems like word problems are actually solved by humans. So they had to pay these guys in Nigeria, big bucks to essentially do huge number of step-by-step solving of these problems. This is not your Khanna guide and Arun's guide. This is for IIT and aspirants. It is doing many instances of very, very similar problems with their derivational traces, and then use them in the pre-training phase. And so, in fact, OpenAI had to spend a ton of money, to do that. And the last thing, which I already mentioned, is even if you stuck to just purely factual data for training LLMs, it doesn't eliminate hallucination. So if, in fact, you only trained LLMs on Wikipedia data, which you would largely assume is pretty factual, it can still hallucinate because it's not remembering each Wikipedia article as a separate article and retrieving it. So it very well might give me awards that I don't have and remove the awards that I do have, etc., in generating completions about me. This is just par for the course, and it's worthwhile remembering that. If data is a bottleneck, the question is, can we just make LLMs train themselves with the synthetic data? And the problem is, yes, that's possible, but the problem is, where are you getting the synthetic data? One idea that people have is LLMs generate their own data and test it themselves for correctness and use it for further training. This is sort of blind leading the blind, essentially. And it turns out that we have a lot of work showing that LLMs are actually extremely bad in doing correctness verification. They're okay in doing style verification, but they're extremely bad in doing correctness verification. And there are lots of papers still written saying they can do it. That's because people wind up confusing correctness with style. The other idea, which is more reasonable, is actually to use external solvers to generate the synthetic training data. And it's sort of like using an external system too. I'll talk about system to system in a minute, but using an external system too to essentially compile what it does into my own system one. People do this. People actually have both system two and system one, and they compile. Once you have solved a problem once, you try to remember it so that next time you don't have to redo it from scratch. But here, you're essentially depending on these external solvers to do this. And so as a joke, to kind of understand that the synthetic data conundrum is that you might be ignoring the cost considerations. It's not yet clear whether, in fact, the cost considerations are being met by this sort of synthetic data generation. Because, for example, imagine I'm trying to make an LLM generate synthetic data for planning. Then it could basically, I'm calling it LAMI in addition, as against Go5, which has been the good old-fashioned AI. Llama is the LLM-fashioned AI, where you essentially call an actual planner, make it solve 1 trillion problems of the same kind, and then fine-tune your LLM with those solutions, just so that you can solve one more such problem. And the question then is, did all this work that you spend fine-tuning GPT-4 with this external solver, has it been paid for? And as I said, sometimes if it's the human solving it, you actually have to pay big bucks. And even when you have external solvers, you may have to pay compute money for that. And so in general, one of the things to keep in mind is that in this new age of LLMs and generative AI, we have started kind of forgetting about some of the lessons of computational complexity. And somehow we assume that the offline computation doesn't matter at all. How much our time you spend offline, hopefully it will get amortized in the online use of this offline computation. And whether or not this actually is true is going to be deciding whether many of your and your friends' startups are actually going to live to see the next month or next couple of months. Okay. The other thing that's a positive thing about LLMs is LLMs are actually approximate knowledge sources. And so the idea is that in the Go5 used to be basically the way you would write AI systems is you would talk to a human expert and then try to come up with their expert knowledge. You, the knowledge engineer, will write it as rules, and then you somehow feed it to the computer. And that was considered the expert systems style, knowledge-based style approach. And that's been widely panned, saying that's a pretty silly idea. But really, you can redo this now with a whole bunch of those pieces kind of approximately supported by LLMs. So the LLM will give you the domain knowledge. You can ask it, okay, what are the actions, potential actions in this domain? What are their preconditions? What are their effects? And it will give you some general answers. And the human can do some amount of work to correct it. And then it becomes a model, which can then drive a model-based system. So interestingly, as I said on that right-hand bottom, if you give what you know about a toy world to the computer and have it solve new instances, that's considered kind of go-fi cheating. If on the other hand, you capture all that the humanity knows about everything and anything and feed it all to your LLM and then ask it to do some toy world instances, that's actually modern AI. We are doing some of that right now. Many of the startups are actually doing that. And in a way, if you want to understand how the LLM use is going on, you are better off understanding the background of knowledge-based systems, just so that you won't reinvent the wheel, because some things, many of the people doing it have come into it only after neural networks and don't actually know anything about knowledge-based systems. So in fact, that is a thread that basically talks about the common misconceptions, because it's hilarious that LLMs are making symbolic knowledge-based AI relevant, but in the process, merely exposing the ignorance of many people who have actually ignored learning about that. And so if you don't, then you are, as Santayana said, those who ignore history are condemned to repeat it. Although actually it may not be as much of a condemnation as getting a free New Rips paper these days in AI. If you forget what happened in knowledge-based systems, you can reinvent it. So the last two things that I'm going to spend some time on, I understand that will be late, but as I told Ravi, I'm willing to stay longer if there are questions after I'm done. And so if you're interested, then I'll stay. But anyway, the two things that I want to mention at least are the LLMs. Are LLMs AI complete? One of the biggest issues is there's always this AGI worries, AGI is going to kill us all, et cetera, et cetera. So the question is LLMs equal to AI? In fact, one of the things that is the one that kind of annoys me the most is people assuming LLMs and say AI when they actually just mean LLMs. And one of the hopes of this talk is that LLMs are a particular type of AI technology, which their advantages and disadvantages, and you should know that. Don't equate it to AI. In particular, what else is there that they certainly can't do, for example? So it turns out that one of the things AI systems should be able to do is basically what the humans are able to do, which is, in addition to what LLMs do, we can do reasoning and planning and so on. And the question is, are they, first of all, I'll show you in a minute that they can't do them very well right now, despite the fact that there are all these papers being written on this. That's actually my research that has been published. The question then is, okay, maybe they're not showing reasoning and planning right now, but if we increase the amount of data and increase the number of parameters, maybe they'll start doing it magically. I hope that by the end of this talk, you would severely doubt that kind of an optimism. LLMs are never going to be becoming system 2. That's that picture there that, from the late Kahneman, who passed away very recently, has basically talked about this metaphor for human thinking, which is in terms of system 2 and system 1. System 1 does the reflexive behaviors, and system 2 does the deliberative behaviors, or the reasoning from the first principles. And if you think from that perspective, where LLMs are really a system 1. It's a ginormous external system 1 to all of us, okay? And it's been trained on all our data to be a system 1, but it cannot. There is no reason to believe that they're actually able to do system 2 kind of deliberation, partly, for a variety of reasons, including, for example, that imagine the following thing. If you ask LLM in a halting problem, that means would this program terminate? And those of you with CS background, you know that halting problem is an classical undecidable problem. So you can't actually answer this for any arbitrary program. But when you give this prompt, LLM would say yes or no, like right away. It will take constant time per token. And so there is no actual thinking going on necessarily. It's not even taking extra time. So you can always say, well, make it pause so that it looks as if it is thinking, but that's like cheating yourself, okay? So it's worthwhile keeping that in mind. One of the issues is as to why people think LLMs can do like reasoning and planning when possibly they cannot, is because the approximate retrieval appends our intuitions regarding their guesses. One thing that I want you to remember is computational complexity of the underlying task has no bearing on the LLM's guesses. As I said, it will give the next token in the same amount of time, whether the prompt you gave corresponds to an undecidable problem, or a semi-decidable problem, or a NP-hard problem, or a polynomial problem, or a constant time problem. Okay, and so you have to ask yourself, where exactly are you thinking that somehow computational complexity is going to affect LLMs? One of the weird ways it actually affects people's thinking about LLMs is they think maybe they can't do planning, but they can verify the plan, because verification tends to be cheaper than generation of the plan. But unfortunately, that too is an algorithmic reasoning, and it turns out that LLMs cannot actually do correctness verification. We have papers on this, other people have papers on that. They can do style verification, but they can't do correctness verification. And the usual dimensions that make AI problems harder, such as stochasticity, partial observability, etc., they don't matter to LLMs because they're just guessing the next answer. So you can think of that as a feature or a bug, but you should be aware of it. After all, as I said, they take constant time per token. Background knowledge is easier for LLMs approximately, and that's the great thing for them. And because they have background knowledge, sometimes what they do might look like reasoning to you. Because in fact, I have this joke that there's this old interview question that I'm sure many of you have heard of that apparently Microsoft used to ask, which is, why are manhole covers round? Okay, the very first time that question was asked to a poor interview candidate, they had to actually probably think about why manhole covers have to be round. For example, if there's any other shape, maybe you can make them fall down, all that stuff. But most of the time now, people have looked at the interview questionnaires, and so they actually will answer the question pretty fast, or maybe they're smart, they will act as if they're thinking for a bit and then give the answer. But that doesn't mean they reasoned, they actually just remembered the answer. And LLMs, because they have such web scale corpora of knowledge, sometimes they might give answers that happen to be correct, but they don't know that it's correct. And so you still have to come out and verify whether they're correct or not. And in fact, they are pretty good at, with no guarantees, in coming up with common sense knowledge, coming up with domain knowledge, coming up with theory of mind. That is, what might people be thinking if I say the following thing, coming up with analogies. And you can use these in building compound systems with LLMs as part of the thing. I mentioned that LLMs can't do planning, and this is actually one of the slides from our work. And in fact, it's pretty, we basically showed that something as simple as stacking blocks in some configuration, given they are in some other configuration, we started showing, starting like 2 years back, that GPT-3 couldn't solve them. And then GPT-4 came, it went up to, let's say, 30%. And we then showed that, in fact, probably it's because it actually is doing approximate retrieval than actually solving. And the way to show it is you change the names in terms of the actions. Instead of saying stack and unstack, you might say attack, for example, attack block 1 with block 2. And the names shouldn't matter in terms of the actual planning domain. And normal planners can actually solve it correctly. But then with the what's called the mystery blocks world, you notice that GPT-4 is 4.3%. What's more interesting, GPT-4 Turbo is 0.83%, Claude 3 Opus is 1.3%, and Gemini Pro is 0.4%. And again, even for normal blocks world, it's not like they're getting 100%. So you have to understand that there are no actual guarantees that they can solve planning and reasoning correctly. And the reason people, again, tend to think it's possible is that they're good at approximate retrieval of plans, but that sometimes may be confused with planning, but it's not planning, because planning involves both the knowledge and the actual verification that the plan that you came up with is correct. LLMs are good at kind of coming with the approximate planning knowledge, but they're not good at, they have no capability of verifying the correctness. So if you don't believe me, this was there was an article in the New York Times last year, which basically showed that people, basically Amazon was full of these travel books that were written by ChatGPT with travel plans, et cetera, et cetera. And people were buying these instead of Rick Steves' books because they were cheaper. and then they were promptly returning it, because when they actually go to the museum, it looks, the pictures are good, the general idea of the museum, where it is, etc., are good, but it misses all the logistics. For example, they might go to the museum and find that it actually is closed on certain days, or you're supposed to have the tickets beforehand. And so it's basically a useless plan. It looks like a plan, it has the vibe of a plan, but it doesn't actually execute. And my joke is, you can make LLMs to make wedding plans for you, but I hope you won't. First of all, if you are from my age, I hope you're not getting married again and again. But for those of you younger, if you are making a wedding plan, don't get married with a wedding plan, because the logistics matter, in fact, whether or not wedding actually will take place. So this is actually a slide from my normal talk I gave last week. I gave it at Google DeepMind. I'll show you a video link later. That LLMs by themselves cannot plan in autonomous modes. They can't do planning in autonomous mode. Chain of thought, fine tuning, etc., don't help. I'll show you a little bit about chain of thought in a minute. They can't improve themselves for self-verification. And having humans iteratively prompting is an invitation for clever hands effect. But at the same time, they can support planning by being a universal guesser that is then verified by an external verifier, which itself can be teased out with semi-manually from the LLMs. So that's the way of using LLMs. So the chain of thought prompting idea basically is this idea that people have, that somehow you can tell LLM the steps involved in solving some examples, and then it will figure out how to solve other examples of the same kind. So for example, in blocks world, one way of always solving the blocks world is put all the blocks in the initial state on the table, and then actually put in the correct stack in the stack that you need in the goal state. It turns out humans can do it, but just because humans can do it and it's in English doesn't mean that LLMs can do it. And in fact, we have shown, and other people have also shown similar things, that chain of thought prompting is extremely limited and it doesn't generalize well at all. So there are people basically assuming that chain of thought prompting is a silver bullet, but unfortunately, it also isn't. I'm tickled enough about this whole chain of thought prompting that this was my April 1st tweet this year, that a forest of jumbled thoughts prompting an ultra general way to use LLMs for solving planning, reasoning, world peace, and climate change tasks. And you should read the abstract. It's made up, obviously to be funny, but surprisingly enough, the current zeitgeist is so much that anything you say LLMs can do, people will believe you. Anything you say LLMs can't do, people are a lot more skeptical, because essentially we are in the rose-colored glasses way. And so actually more people ask me for this particular paper, which doesn't exist, than the real papers that we write. Again, this is actually a slide from talks that Jan LeCun gives, and he basically keeps pointing out our work on the planning part, along with other people's work, showing that planning and reasoning are not easy for LLMs. This brings up the agentic LLM gold rush. I want to hit on all the big buzzwords that you may have heard of before coming here. So agentic LLM gold rush, you have to understand that starting an action is very different from planning to make sure that the actions you do will have desirable outcomes. Anybody can start an action if they have effectors. A kid left with a gun in the home will be able to fire the gun, but you don't want to leave the gun in the home with the kid, because the kid is not a particularly good planner, okay? And so, in fact, in the case of agentic LLM, you have to ask yourself, you should be very careful that you should think of them as orchestration frameworks for LLMs, and you are making sure that the orchestration is correct. If you let the LLM just orchestrate out of, by itself, and if you are in worlds which are non-ergodic, that means once you die, you can't come back, which is our normal world, then you are asking for specific trouble. In general, I would think that we are ready for L2, L3 automation for agents than anywhere near L5 automation, if you think in terms of the self-driving metaphors. So I said these LLMs can't plan, and they can be used in LLM modulo way. And that's a picture of LLM modulo architecture. There's a paper that I'll show you in a minute that you can read later. But the basic idea is large language model is being used to suggest plans, to suggest domain models, to expand the problem specification. But then there is a critique. There are these critiques, binary critiques, constructive critiques, and style critiques, which will make sure that the suggestions are actually correct before sending them out. And if they are not correct, they'll back prompt the large language model to come up with additional candidates. So this is a generate test model where as long as the tester is sound, you will never give an unsound solution. And it turns out we show that actually these verifiers themselves can either be teased out from LLMs. In the case of correctness verifiers, you can get the model that runs this critique from the LLM, by teasing it out, and there are papers on that. And if in the case of things like style cases, actually LLMs themselves can be critiques. They can do a reasonable job of style critiquing. This is the paper that that talks about LLM modulo frameworks, and this is a talk that I gave last week for Google DeepMind reasoning with LLM seminar. As I mentioned, the one thing that LLMs are good at doing, even though they cannot do correctness, they are reasonably okay at doing style criticism. And so, in fact, this is actually the only place where I'm mentioning VLMs, which is vision language models. And we have a paper, for example, showing that if you show a robot behavior that achieves the goal, for example, give me a pair of scissors, and it gives the pair of scissors, but it's trying to give you the pair of scissors with the pointy end pointing towards you, you tend not to like that generally. If robots giving you knives and scissors with pointy end pointing towards you is the last thing we want. And so, in fact, GPT-4V can provide criticisms that are reasonably good at showing those kinds of behavior style errors. One last thing is, I already mentioned this, doesn't Copilot for code show that LLMs can plan? No, because ability to approximately retrieve code segments is not the ability to reason and plan. And in fact, if you can write programs with guarantees, then everything else is solved already, because planning is just a subset of it. And also, the way Copilot is used is very much as a cognitive arithmetic. Copilot has humans in the loop who will check, and most of the time, maybe they're happy with the program, but every once in a while, you'll read it on the internet, on the Twitter, that somebody will say, I just spent 4 hours trying to find this really bad bug that Copilot introduced in this just 25-line program, for example. That can happen. And the other thing to keep in mind about GitHub is GitHub and general web are quite different as training corpora. People don't put their non-working code on GitHub. General web has 4chan. The day GitHub has 4chan, then I would be interested in figuring out whether, in fact, Copilot can do program suggestions well. The very last thing, which I actually would just show you, but I'll answer only if you have questions, is that there are a whole bunch of things that we could talk about societal angst, about generative AI, worries like plagiarism. LLMs can do reasonably well in JEE. Most of those happen typically in the multiple choice questions. And again, part of the reason it happens is because all the question banks are available. It's not to, there is enough information about any standardized exams that is available that winds up actually making it possible to answer them well, by these kinds of LLMs. There's the whole issue of deepfakes. There's the issue of bias. They get the style of the articles, and if the style of the articles contains biases, then they're going to, let it grow forward. And there's this existential angst. To me, LLMs themselves don't actually kill us. In fact, if you use LLMs in these agentic frameworks and they give them guns, then you can get yourself killed because they don't have good ability to do planning. So that's the agenda that we went through. And the last thing is summary, that thanks to their approximate omniscience, LLMs present an amazing resource. There's a temptation to confuse their approximate retrieval capabilities for factuality and AI completeness. But I hope that you understood where the limitations are. They can provide approximate knowledge about almost any task area or question. And this is ushering in a new resurgence of approximate knowledge-based AI systems. So you may want to actually think about what those were doing beforehand so that you don't have to reinvent the wheel. And then finally, LLMs can play many constructive roles in hybrid reasoning systems, such as LLM modulo frameworks that I showed you. And the very last parting thought is, those of you who heard of alchemy, you may remember that alchemy, there was nothing wrong with chemistry. Chemistry was a beautiful subject. You and I took chemistry. The problem with alchemy was a bunch of bozos thought chemistry can be physics, nuclear physics, if only you prompted just so. And that turned out to be the actual problem with alchemy, not that chemistry is bad. LLMs are similar. LLMs do what they do very well. the joke is on you if you think that they can do things that there is no reason to believe they can. And I hope you got some of that. And thank you for your attention. I am impressed that there seem to be some like 175 participants still showing up here. So if there are any questions, I will take as much time as you want to hang around. But otherwise, thank you for your attention.
Thank you, Professor Rao. This was a very informative, insightful, and enjoyable talk. I'm seeing comments. People are suggesting they will probably attend your comedy show if you once you retire. It's enjoyable. Truly.
If you see my LinkedIn profile, I say my actual job is stand-up comedy for my students. So yeah.
No, it's wonderful. We have covered a lot of ground today, from the basics of ChatGPT and large language models in general to agentic LLMs, and so it's very wonderful of you to take that time to spend with us. The links to the slides has been posted now, I'm told, by Swati Deshpande, our executive director. This is posted on our website at iit.org, so you can access the slides from there. Also, I tried to post them here in the chat. There are some questions. There is this one, Professor Rao, from Oro Tripathi. He says, what's your point of view on in-context learning?
Yeah, so in-context learning, we talked about it. Let me see if I can get back that slide since I have the slides here. So in-context learning, I talked about this in the context of that slide with prompting and fine-tuning. There, okay. So in-context learning is prompting, essentially. And it's not actually clear why people decided to call it learning, because typically learning means something changed in the architecture that you have learned. In-context learning, obviously, is just changing the prompt so that the specific conditional distributions that you are accessing are going to change. The problem is you think what should be the prompt based on how humans will actually consider the prompt in figuring out their response. But your intuitions about that don't necessarily coincide with what LLMs actually do, in fact. And so that's basically the slide where I talked about prompting and in-context learning. In general, there is a probabilistic guarantee that if you sort of ask them to try again, come up with a different plan which has the following actions, it will try to give a new candidate which sort of adheres to that prompt, for example. But it may still wind up having other errors that were not, that you still have to check, which is why in the LLM modulo framework, the back prompting is essentially using in-context learning to send, feedback to the LLM about its guesses, saying, the guess is wrong, try the following changes. The guess is wrong in the following places, etc. And so that's what I would say about in-context learning. In general, in-context learning is pretty much the only thing that most of you people who are not retraining the LLM have access to in general. And so that's what most of the prompting strategies, etc., the quote-unquote prompt engineering has become that. But as I said, whether or not prompt engineering works depends on whether you know what you are expecting as the correct answer. And sometimes you ask a question knowing approximately how to tell whether the answer is right or wrong. And sometimes you're asking a question because you truly don't know the answer. I don't know, maybe some of you don't know what is the Belize, capital of Belize. And no amount of prompting is going to make sure that LLM will only give you the correct answer to that question, for example. So completions will be, in-context learning is essentially sort of changing the completion directions, but that's basically it.
Another question is from Trip Chaudhary. He says, any thoughts on mixture of experts, as in Mistral LLM?
So there are, I think the LLM modulo can be thought of actually in that sense too. I'll just put that back here again, that the LLM modulo can be thought of as a mixture of expert verifiers which are sitting outside of the pre-trained LLM. Okay, so you might decide to talk about, training the LLM itself originally as a mixture of LLMs, whereas here I'm actually assuming that you have one GPT-4 or one Claude, and I am using these mixture of verifiers, a bank of verifiers, to check the correctness and validity of the LLM's answers with respect to variety of criteria. In the case of planning, for example, I might be looking for timeline correctness, resource correctness, etc., each of which are different, verifiers, and they can together work to actually ensure that there's a higher guarantee for the guesses that LLMs are making. So that's probably my answer. In fact, there is, in general, LLM modulo that I'm obviously very fond of because we came up with this. But there are other people who are in general talking about putting LLMs with other components. And there is a different name that these people have made called compound AI systems. And I would say then, LLM modulo is a kind of a compound AI system. And the question then in those cases, including here in LLM modulo, is how do you kind of optimize this overall architecture with pieces outside of the LLM. In the case of LLM modulo itself, it turns out that actually the models that are underlying the critiques themselves can be learned from LLMs. We have a paper in URIPS which tells, for example, how you can semi-automated fashion get planning domain models from the LLMs themselves, which you can then give to a plan verifier, which can then do back prompting on LLM guesses.
Thank you, Professor Rao. Another question by Salesh Nirgudkar says, what is the maturity of sentiment analysis in the current LLMs?
So that's actually a very interesting thing. And let me answer this in the following thing, in a bigger sense, that when I was a grad student, there used to be this area called natural language understanding. Okay, natural language understanding is actually AI complete. That means, at least for a large amount of AI, other than, let's say, motor skills, etc., if you can really understand natural language, you can understand most of the civilizational tasks that we do, because we do everything in terms of language. That was too hard, and that somewhere along the line, NLU people rebranded themselves as NLP, natural language processing. And it turns out natural language processing, if this is NLU, which is kind of the full intelligence, NLP is kind of on the other end is the information retrieval systems. And NLP became closer to information retrieval systems. And the kind of questions that they would be looking at are things like sentiment analysis, summarization tasks, etc. And unfortunately, whatever specialized methods the NLP community came up with are no match for what pre-trained LLMs are already able to do. Okay, you can always come up with some examples of you got the sentiment wrong, but the specialized sentiment analysis ones were also going wrong. It depends on, to the extent understanding the sentiment involves deeper reasoning. Since LLMs can't do reasoning, they will fail in those cases. But it's not like there is any other competition from the NLP community that does better in sentiment analysis than LLMs. So if you're doing sentiment analysis right now, I'll just do LLMs, as those are the things that they are actually good for out of the box. In fact, one of the funny things is the NLP community is having a bit of an existential crisis now, because what is left if you are doing information extraction and summarization and sentiment analysis as your bread and butter, and that can be done very easily by these pre-trained models, then what can you do? And most of them now suddenly are in the bandwagon of reasoning and planning, which is part of natural language understanding, but has been completely ignored somewhere in the middle. And so that is part of what's going on actually in that community. So, the simple answer to your question is LLMs do pretty good. And there's no better approach anyway for sentiment analysis, unless you wind up actually doing full-on reasoning. So the only places where they'll fail would be the ones where there are, for deeper reasons, essentially, the overall thing winds up having a negative sentiment, even though it is using positive words, for example. But mostly they're able to do pretty well compared to any other sentiment analysis systems.
Thank you, Professor Rao. There are a few questions on AGI. Maybe you can talk about it a little more. But one of the questions says, this is from Vikash Kodati. He says, considering that LLMs operate on statistical learning governed by computable algorithms, systems subject to limitations identified by Gödel and Turing, could these constraints prevent LLMs from achieving true human-like cognition and ultimately reaching AGI?
So, I mean, first of all, I think the AGI, whole AGI discourse is a mess. And I'm not very sure that there are clean answers that would make sense in a technical forum as yet. In terms of incompleteness theorem, it's not at all clear to me whether Gödel's incompleteness theorem actually has any impact on whether or not you can get human-level AI systems. By the way, Gödel's incompleteness theorem actually applies to us too, and we somehow are doing whatever it is that we wanted to do. In general, actually, in my own time in AI, back when I was a grad student, the books on AI would all be saying AI is not possible. Like, in fact, there's this guy called Roger Penrose, who is a theoretical physicist, who then decided that he would rather write books about how strong AI is actually not possible. And he writes these very large books, which with questionable, I mean, he's a very smart theoretical physicist, but the argument he was making as to why something cannot be done were not actually holding water. And then the pendulum has swung now, and basically people are seeing AGI as at every corner these days. And in general, I think some of the people in technical literature, especially those I respect, tend to think in terms of capabilities and than in terms of this nebulous idea called artificial general intelligence. And the other thing I want to mention is we should not confuse ability to do damage with intelligence. Thermonuclear bombs can basically take out the earth many times over. We have enough thermonuclear bombs. The last time I've checked, nobody said thermonuclear bombs are particularly intelligent. Okay, so it's this worries about somehow AGI will kill us all requires certain level of suspension of disbelief, in my view, because it's confusing ability to do damage with actual intelligence. It's not as clear cut.
Thank you, Professor Rao. There are a number of comments complimenting you on a brilliant talk. Sunando Ghosh says, that was so much fun to listen to. Thank you, Professor Rao, for making this so interesting and informative.
Thank you.
So wonderful. We can go on. We are over time quite a bit, but anybody who wants to stay back and listen can stay back. We will continue with the other questions that are still outstanding. Professor Rao, please feel free to pick some from the
No,
chat.
I would prefer you pick, because it's very hard for me to read as well as answer. I mean, I might answer some of these questions later on Twitter or something if
Sure.
I don't get around to them, but I would much rather you pick, because it's very hard to multitask that way.
Sure, absolutely. So one of the questions is this is from Shubhankar Dhar. He says, what will be the impact of LLMs on education, particularly computer science education and evaluating assignments when students are using LLMs to generate code?
Yeah, in general, that's actually a very interesting thing. And that's a whole entire talk that we can have. As I said, I just showed one slide, but basically I have written articles as well as given talks on the general societal impacts. That tends to be the thing that I wind up doing more often, because everybody wants to know about them. But since you guys are IIT folks, I thought we would much rather have fun talking about technical capabilities and limitations. But coming back to the impact on education, let's get real. Part of the reason the educational evaluation systems developed the way they developed are both because of the limitations of humans, in the sense that they can't read up the entire web and just regurgitate in some form, and also because the limitations of poor teachers like me. Actually, the least interesting way to ask questions to people is multiple choice questions. And we do multiple choice questions not because they really are the best way to gauge somebody's understanding of a subject, but because they're actually easy to grade. Okay. In terms of essays, the English teachers used to give essays, and the what they were looking at oftentimes is sometimes you can read the entire essay, but if you have 600 people in your class, you probably look at the overall essay and see, is it in kind of good style and make your life easy? And unfortunately, that went out of the window because with LLMs, everything is in great style. And unless you read closely enough, you won't actually have the sense of whether it's a good essay or not. And that makes the life extremely hard for teachers. And of course, there are people who are saying, why don't we have LLMs grade LLM written essays? And this is not a joke. Honestly, this is something that people have been talking about. And there is a whole entire worries about that because all they will check is style of the essay. And, style is important, but, I think I'm assuming that we all care about content too. Coming to the whole programming assignments thing, again, honestly, it's a autocomplete. With the Copilot, you essentially doing an autocomplete. And so we have to think of what are better ways to evaluate. There are one of two things we can do. One is all of us get those Faraday bubbles and put people in the Faraday bubble so that no cell signals, no electromagnetic signals will go, and then make them write the programs. Or you can essentially say instead that we will actually assume that you have the web at your fingertips, but here is an interesting new task for which, as far as we know, there is no actual piece of code that directly applies, but you have to still figure out whether or not you can write that code. This later is a better way to teach, but it's much, much harder. And as a society, we are going to have to come to terms with this. Believe it or not, at one time, before the advent of calculators and slide rules, we would consider ability to do multiplication correctly, etc., during exams as a sign of intelligence. And then, calculators came along. There were all sorts of worries as to whether, in fact, math education will even remain possible, etc., etc. And here we're still doing math. Calculators are there, and you wind up using them. So it makes us think freshly about the corners that we cut before, because we knew that people didn't have access to these kinds of technologies. One thing that I want to mention right next to this is much of the civilization, not just the education, developed based on what we are able to, what a normal human is able to do. One of the interesting things that you might all be thinking about is this whole copyright law. And New York Times is suing OpenAI, as are many, other companies are suing, other newspapers are suing OpenAI, saying, OpenAI is infringing on the copyright. And, OpenAI says, this is fair use. We just looked at your articles. We are not reproducing them verbatim. But the question, as Melanie Mitchell once pointed out, is do this thought experiment. Imagine a world where all of us had omniscient photographic memory. How would copyright law have evolved then? And just as doing exams the same old way with the advent of LLMs makes no sense, sticking to the same old notions of copyright may not make sense in the advent of things like generative AI systems. And as a society, we have to figure out what do we think is a reasonable way to enforce intellectual property and copyright. It's fun time. I always thought that other engineering disciplines solve the problems that exist. Computer science generates the problems and then solves them. So we'll never go out of business. So we generate all these new problems for the world at large with this kind of generative AI technology, and we can help them solve it.
Very good. And we will take maybe a couple more questions.
Okay.
And we encourage people to ask Professor Rao questions. He's on LinkedIn. He's on Twitter. He's very active, and you should
please use Twitter more. That's more easy for me, but that's fine. Yeah. Go ahead.
There is a question on autonomous vehicles. We have a session, by the way, in 3 weeks on May 25th that goes into robotics and autonomous systems. But there is a question here by Shailesh Nirgudkar. He says about self-driving capabilities in autonomous vehicles. What do you think is the key roadblock there, in your opinion?
There isn't much of a roadblock. I'm in Tempe. I'm speaking to you from Tempe, and I'm basically driving. with Waymo cars on the side. It's become normal day to day right now. Within urban driving, Waymos are all over the place. Again, they took a long, long time. In fact, Tempe and Arizona turns out to be like the crossroads of autonomous driving industry. We basically, because of our government and the governor having open hands and saying, come on over, check out your autonomous vehicle technology. Here, we had Uber, which basically had no business doing self-driving, also drive their autonomous driving cars, and they actually killed a person not more than about 2 blocks from where I'm standing right now. But Waymo, on the other hand, did a lot more training, and they certainly seem to be doing much better. I agree that ultimately I always assumed that driving in Hyderabad, driving in Madras, driving in Delhi is true AGI. That requires true AGI, which only Indians have, and probably AI systems still don't have. But however, the other day, in fact, 2 days back, I saw some company in Madhya Pradesh, I believe, which had this Jeep that was basically self-driving Jeep. Oh, and you should see this on Twitter. I mean, I'll probably retweet that just so in case you want to look at it. And that thing is just driving like a maniac, avoiding all the bullock carts, all the cows and all the dogs and all the people crossing the road. And it was still doing fine. I mean, not too many people are dead, at least during that video. I don't know what happened earlier. But in general, my sense is that I would actually say that autonomous driving is one thing that is actually coming closer to being real. It's already real. If you come to Tempe, it's completely real, because when I actually in here, Waymo is connected to Uber. So when I ask for a Uber drive, Uber might just say, well, by the way, there is this Waymo available. Would you like to take it? And they're actually 20% cheaper, believe it or not, because they don't have to actually pay their drivers and so on. So I would say that there is never any 100% guarantee, but I think, in fact, autonomous vehicles have been much more of a reality. I would think of autonomous vehicles in general as deep and narrow systems than broad and shallow systems. And in general, deep and narrow systems doing the one thing that they do well have much better guarantees. AlphaFold, AlphaGo, Deep Blue, autonomous driving, self-driving, etc. It's the broad and shallow systems and the combining of those two which will raise more questions. But I think in general, I'm much more optimistic about autonomous driving, because look, I'm just actually driving to come to my office this morning. I passed 2 Waymos. Okay, and sometimes they make a left turn over me fully legally, nothing wrong with what they're doing. So I haven't yet found anything to be too worried about. I know that you guys in San Francisco have started torching some of them. That's an entire Butlerian jihad. Those of you who know, and that's a whole entire question. The issue of what happens to the human jobs when all the jobs are taken over by these technologies is a very interesting question, and we can always have a lot more discussions on those. But right. Yeah.
Thank you, Professor Rao. Last question, and I will rephrase this, paraphrase this. This is from Dr. Satish Salpekar. He's basically asking that do you foresee this sort of the limitations that you highlighted in large language models to persist over time, or do you envision a future where some of these restrictions may be lifted and it could truly transform into something different?
So that's a great question, and it's actually a very good question to end because it makes me repeat things. LLM is not equal to AI. And I actually mentioned this when I had that slide about LLM versus AI. And AI systems will eventually continue to take care of all these limitations. But LLMs themselves are not going to be able to do so because LLMs are these auto-regressive models. They have all sorts of inherent limitations. They're doing extremely well in what they're doing, but increasing the context, which we have been doing from GPT 3.5 to now, you can have million-word context windows in Claude 3, for example, to having more layers, etc. None of that is going to change the essential limitations that we are talking about. In general, you can convert the reasoning into retrieval by maybe remembering all the answers to all possible questions more, by training on more of the data. But that still doesn't change the fact that reasoning and planning are things that LLMs are not actually doing, and increasing their size is not going to change that. The kind of ideas that people are trying, unfortunately, keep the LLM autoregressive nature the same and talk more about things like self-driving and this kind of self-training, etc. That doesn't change, as I pointed out, the major limitations. There are other people, including these compound systems, these LLM modulo kind of systems, etc., which already remove those limitations. If you're talking about a pre-trained system that removes all those limitations, it would not be something that is just GPT 7.9. If GPT between iterations doesn't change its architecture, which it hasn't since GPT-2 to now, it's essentially the same autoregressive architectures. In fact, there are other interesting points to be made about the limitations that I didn't even go into, that the way they actually wind up doing learning itself, it's called what's called a teacher-forced learning. So if you get back to my IIT Madras example, the teacher-forced learning is the one where you are always giving the prefix and trying to decide the last word. That's the way you train yourself on the data. That in itself is a particular kind of, that in itself brings up certain kinds of limitations. In general, autoregressive nature and teacher forcing are going to, especially autoregressive nature, is going to be enough to make sure that they cannot do reasoning. Can they fake reasoning? That's an entirely different thing. One of the comments that I make to my students is a society is considered civilized to the extent that bozos who don't think can still survive, because everything basically follows some script and we just basically don't have to think from first principles. And most of our society is indeed like that. It's been templatized compared to, for example, the societies where our ancestors, many ancestors, used to live in. And so I mentioned that the last time I know for sure that humans had to do true reasoning rather than just remembering the answer approximately was when those kids, their plane crashed in Colombia jungles, and they didn't have access to Google, they didn't have access to LLMs, and they had not trained on how to survive if you fall in the jungles, and they still somehow survived. That is, so one interesting point about reasoning is that in the day-to-day world, you actually standardize the world enough that essentially faking reasoning by memorization would be more than enough, and you won't be able to tell the difference. But that is different from whether, in fact, LLMs are capable of doing reasoning. And I guarantee that, as far as I know, that autoregressive models will not do that. The other technologies that will come, including the compound systems right now, will be able to do it. Its AI systems have always done reasoning. It's the LLMs that can't do reasoning. And if you say LLM equal to AI, then you'll get confused. Okay.
Thank you, Professor Rao. Again, what a wonderful session. We are almost half an hour over time. I apologize to all the people who posted their questions that we could not cover today. But as I said, please reach out to Professor Rao directly on LinkedIn. Also, the recording of this session will be posted on iit.org, so you can access it from there. And the slides also are accessible through there. Please register yourself at iit.org if you want to receive notifications about the upcoming talks. Our next talk will be on May 25th on robotics by Professor Dinesh Manocha. And it should be an interesting talk covering some of the important aspects of AI. Thank you again for your interest, and thank you for joining today. We appreciate it.
And from my side, thank you all. I see still 110 people who have not yet logged off. So that is what makes me happy. As you know, giving these talks is actually quite nerve-wracking, especially when Ravi keeps telling me that the number of people registering is increasing, like the AI hype. So I'm happy that people who actually logged in stayed this long, and thank you for your attention.
Yeah. Thank you, Professor Rao, for taking the time. We really appreciate it. Goodbye.
Thank you.